Good afternoon, everybody. I'm very thankful to the organizing committee of IWUMD 2022. Today I will talk about the remarkable light extraction enhancement in UVB LED by using nanoPSS and photonic crystal in p-AlGaN contact layer. Here is the outline of my presentation. First, I would like to talk about the UV LED application, our recent results, and the objectives of the optical simulation, method used in the simulation model, and then I will analyze the result of nano-pattern sapphire substrate in AlGaN UVB LEDs. And subsequently, I will analyze the result of nanoPSS plus reflecting photonic crystals in p-AlGaN and p-GaN contact layer of UVB LED. At the end, I will summarize my talk. A UV LED has a lot of applications. We can inactivate viruses, for example, SARS-CoV-2 coronavirus in human body, as well as in public spaces by using 222 nanometer far UVC LED. We can use UVC LED for the food preservation and disinfections, air sterilizations, and water sterilization too. UVB LED can be used for the immunotherapy like skin atopic dermatitis, vulgaris, and cirrhosis. And we can enrich phytochemical in plants by using UVB LEDs, and we can also inactivate tomato mosaic virus, TOMV, in tomato plants. And UVA LEDs has a lot of applications for electronic components processing, 3D printers, printing and painting, coating, and UV curing, etc. Here is the current status of UV LEDs from UVA down to UVC. Riken got world record EQE of 20% at 275 emission wavelength, and we recently will also achieve a high EQE, about 9.6% in UVB LED. I will just briefly discuss the recent progress. We improved the hole injections by aluminum graded p-type multi quantum barrier electron blocking layer, as shown in this aluminum gallium profile, and also using aluminum graded p-AlGaN hole source layer, as shown in the aluminum gallium profile in the LED devices. By using the polarization effect in this new design of the UVB LEDs, we can get high hole density of 10 raised to power 16 per centimeter square and very low resistivity of 22.94 ohm centimeters. With this new design, we can enhance the EQE from 6% to 8%, as shown in these two papers, and the emitted power also improved from 15 milliwatts to 22 milliwatts. We further improved the UVB EQE by using a very thin nickel layer in nickel aluminum P electrodes, by changing the nickel thickness from 2 nanometer to 0.4 nanometers. Both in T and T mode, we can get very high reflectance, as shown here. And with this new the P electrode in UVB LED, we enhanced the EQE up to 9.6% under CW operations. And light output power on bar wafer was enhanced to 40 milliwatts. Still, light extraction efficiency was found to be approximately under 5 to 6%. IQE also under 60%, which restricts the EQE of UVB emitters up to 9.6%. Therefore, we choose a new optical design for AlGaN UVB emitters to be used for both LE enhancement and also for the reduction of threading dislocation in the quantum well to enhance IQE. Finite difference time domain method was used by following the Bragg condition as shown here. And here is the nanoPSS architectures in these figures. And plane wave expansion method was used to confirm photonic bands of the nanoPSS and photonic crystals. Here is the FTDD simulation model of UVB LED, and here is the typical UVB LED structures. Here's the AP direction, and here's the light directions. So the other parameter is shown here. So we introduced nanoPSS in sapphire substrate and PHC in either in p-GaN contact or p-AlGaN partially to a whole source layer 2 as shown here. A 10 nanometer thick p-AlGaN contact plus 150 nanometer thick p-AlGaN whole source layers was used for nanoPSS before photonic crystal simulation model. First we check the nanoPSS. So here is the nanoPSS architecture of the UVB LED. We introduce here, and the p-AlGaN whole source is 150 and p contact 10 nanometer, and the nanoPSS parameter is shown here, and the radius by pitch ratio of the nanoPSS is shown in this table. According to the results for p-AlGaN contact 10 nanometer pattern and then of order M10 and using height 500 nanometers, we also varied the R by A condition from 0.25 to 0.4 in this modeling. First, we confirm the photonic band structure by using plane wave expansion method for nanoPSS, and the whole type nanoPSS in the sapphire was filled with aluminum nitride. And here is the Bragg condition again, as I mentioned before, and all the working parameters are shown here. And as a result, the light extraction was enhanced up to 18% by using the nanoPSS in UVB LED, as I mentioned before. And here is the R by A value, and the enhanced light is shown as a function of the R by A value. You can see here by using order 10 and depth or height of the whole 500 nanometers. The R by A around 0.38 showing good result. In this study, we also found that whole is better than pillar structure. Next, we investigate p-GaN contact plus p-AlGaN whole source layer as shown here, and by using the same nanoPSS structure which I already discussed. So now we introduce both nanoPSS and photonic crystal. So the photonic crystal was away 70 nanometer from the quantum well as shown here, and here is the nanoPSS parameter which I showed before, and here's the photonic crystal pattern size given in this table. But here the R by A value 0.33 was not optimized, so we use order M4 in this case or 3, and by using these parameters. First, we check the electric field mapping in the UVB LED with nanoPSS and PHC together. Here is without nanoPSS and with nanoPSS, and then with nanoPSS plus PHC. You can see very nice light distribution in the UVB LED. But as I mentioned, that the R by A value 0.33 was not optimized, and the maximum light enhancement was 107%. Excuse me. And by using the nanoPSS plus PHC in this design. After optimization from 0.2 to 0.4 by using the same nanoPSS which I discussed before, and the PHC parameter is shown in this table, and the height of the nanoPSS was the photonic crystal was 140 nanometer, and order 3 and 4 for the light path was used. As a result, we got the LED enhancement around 149% by using R by A value 0.40 in the PHC and using the most optimized nanoPSS parameters for M3. For M4, we got 132%. So in this case, we only use the reflecting PHC and p-GaN contact, not p-AlGaN contact, we should remember. So the R by A around 0.40 was found to be the best value for the design of the PHC. Next, we introduced the p-AlGaN contact instead of the p-GaN contact in our model. Here is the simulation model shown in this device structure. So again, the PHC distance from the quantum hole was 60 nanometer. And here is the PHC, and by using the same nanoPSS, the most optimized nanoPSS, which we got 18% LE enhancement, was used in the same design. And with this, by using both nanoPSS and PHC in the UVB LED with transparent p-AlGaN contact layer, first we confirm the photonic band structures as shown here by using the plane wave approximation. And by following the Bragg condition shown here, and this data in the Bragg condition was supplied in this modeling. We also provided the FTDD condition for the nanoPSS, the same one as I discussed before, but the PHC was, again, the R by A value was varied from 0.2 to 0.4, and the order 3 and 4 was used, and height again was 150 nanometers, similar to the p-GaN contact, but here we are using p-AlGaN, transparent p-AlGaN contact layer. And PHC parameter is shown here. Again, we introduce the whole shape in the photonic crystal. What we got, I will discuss the result for M3 and M4. First M3, we got 143% light enhancement in UVB LED by using nanoPSS plus PHC, but PHC where R by A value was 0.40. So this value was pretty good. And for M4, we got 135% the LE enhancement by using the same condition. But if you compare the M4 with the p-GaN contact, this opaque p-GaN contact, this value is better. So as a result, power was also enhanced in the case of R by A around 0.4, and the light extraction was also enhanced to more than 49% as shown here in this case. And let me summarize my talk. LE was enhanced around 18% using only nanoPSS without PHC, and also using p-AlGaN and without p-GaN contact layer. So with p-AlGaN contact layer and only nanoPSS without PHC structure, we can get 18% enhancement. But if we introduce the nanoPSS, this one, and PHC, and by using R by A value 0.4, the UVB LED was quite improved, and the light extraction was enhanced up to 143 and 135% respectively using M3 and M4. As a conclusion, both nanoPSS and PHC and p-GaN contact layer and p-AlGaN contact layer are equally effective to enhance the LE and to reduce the TDs and UVB LEDs. However, the nanoPSS plus PHC and p-AlGaN contact layer are relatively more effective to enhance the light extraction of UVB LED using order M. As a result, quite high EQE is expected using nanoPSS and PHC structure design in the experimental AlGaN-based UVB LEDs. And thank you for your kind attentions.